Before we get started today on simplifying square roots, what I would like us to do first is to fill out this table for the perfect squares. So what we're going to do is take 2, multiply it by itself. So 2 squared is 4, 3 squared is 9, and you're going to continue to fill out all of this chart. I want you to pause the video right now and fill in each one of these squares. Okay, so now that the table is filled out, let's look at the steps that we need to do in order to simplify or reduce the radicals today. First step is to check to see if the number underneath the radical, that's the radicand, is divisible without a remainder by one of the perfect squares that's listed above. So there's a couple of different ways we can do this. Let's start by looking at number 1. Underneath this radical is the number 108. That's what we're talking about here by the radicand. So the first step says start by checking the largest square less than your radicand and work your way back. So that means that you would take from your chart and you would find all of the perfect squares that are less than 108, and you would try and divide them and see which of those would divide this perfectly. You want to start with the largest because you always want to take out the largest perfect square from any radicand that you have. Step 2 says write the radicand as a product of the two numbers you found in step 1. I'm actually going to show you a way to build a factor tree on this that will kind of combine steps 1 and 2 together. So if we list what all the factors are of 108, we take 108 and we say obviously that's 1 times 108. And then if we start with, in order here after 1, 2 goes in 54 times, then we'll go to 3. 3 goes in 36 times. Right there I have the largest perfect square that will go in 108. So what we do is we take this and we write this as a product of those two numbers, those two factors that we found. And we want to put the perfect square first. So this will be square root of 36 times square root of 3. So we broke down the square root of 108 to be the square root of 36 times the square root of 3. Square root of 36 is a perfect square. That's 6 square root 3. So we have simplified the square root of 108 to be 6 times the square root of 3. So step 3 here says take the square root of your perfect square. That's what we did when we changed the square root of 36 to be 6 and write it outside the radical sign. The number that is underneath that's left is not divisible by a perfect square. You know you're done. You won't have to worry about this number underneath the square root if you are always picking the biggest perfect square from your list of factors. For example number 2, you might not need to build your factor tree if you realize that the smallest perfect square that goes into 18 is actually 9 here. If you had taken this chart and you had said, okay, so 18 would be here after 16. 16 can't go into 18, it's too big. So 9 would be the first one you should try. So that's what step 1 is saying, is work your way backward in the perfect square chart to be able to figure out which one is going to be the factor that you're going to use. So if you did it that way, you could have jumped right to listing this as square root of 9 and square root of 2. So this is 3 root 2. If you had built your little factor tree, and you've done 1 and 18, 2 and 9, 3 and 6, you would have seen it here anyway. Okay, so both are good options to use. Let's go to number 4, and then I'll come back to number 3. So on number 4, I'm going to build my factor tree. I've got 1 times 112, 2 times 56, so far I don't have any perfect squares. 3 does not go in, but 4 does. 4 goes in 28 times. Now 4 is a perfect square, but it might not be the biggest one I have, so I'm going to continue to build my chart here. 5 doesn't go in. 6 doesn't go in. 7 goes in 16 times. Now I've got a perfect square here. Let me keep going. Does 8 go in? Yes, 8 goes in 14 times. So obviously my biggest perfect square factor is 16. So if I broke this up, perfect square factor first, 16 and 7 makes this 4 root 7. I want to show you what would happen if you had chosen to do the 4 instead. Okay, so if you had not kept going on building your chart, you would have made the square root of 4 times the square root of 28, and then this would have been 2 times the square root of 28. Okay, and then this is where step 3 says if the radical, okay, or the number that's left under the radical doesn't have any perfect square factors, you'd be done. Well, this one does, because 28 is divisible by 4, which is a perfect square. So if you don't take out the largest perfect square factor, you're going to have to keep going on the answer of the non-largest perfect square. So this is 2 times 2 times square root of 7. You'd eventually get the same answer, but there's more work to it. All right, so let's take a look at number 3. And number 3, you've got a number in front of your radical that we're going to have to deal with after we simplify this. So we're going to start with the 800. So 1 times 800, 800 is not a perfect square. 2 goes in 400 times. Take a look at your chart that you completed above. You should see that 400 is a perfect square. So 800 would be 400 times 2, and then don't forget that 3 is in front. So the square root of 400 is 20. Then you've got 3 times that 20, which would be 60, square root of 2. All right, I'm going to pause the video now, and I want you to try number 5. I want you to build that factor tree for 135 and find the biggest perfect square factor that will go into that, and then try and simplify the same way that I just did in number 3. All right, so building on factor tree on 135, 1 times 135, 2 does not go in, 3 goes in 45 times, made up of perfect squares. 4 does not go in. 5 goes in 27 times, perfect square yet. 6 does not go in, 7 does not go in. The next number that will go in order after 5 will be 9, and it goes in 15 times. There's my perfect square factor. So for 135, we're going to have the square root of 9 and the square root of 15, and don't forget that negative 4 in front. So negative 4 times 3 times square root of 15 would be negative 12 square root of 15. Okay, I want you to pause the video right now and do all of 6. After you are done, you can unpause the video and you'll see the answer. Okay, so you can see I built a factor tree for 150. I actually stopped when I got to the factors of 6 and 25 because I knew that was going to be the largest perfect square factor I was going to have. So you can see here that I broke down 150 into the square root of 25 times square root of 6, carrying along that multiple of 6 in the front. All right, let's move on to the back. How do I multiply radicals? So the numbers that are outside of the radical sign are going to get multiplied together, and then the numbers that are underneath the radical sign, they will get multiplied together. So let's take a look at number 8 first, because for each of those, it's really clear that there's a number outside. So you've got 3 times 4, which is going to make a 12. And then the numbers underneath the square root are going to get multiplied together. 7 times 5 will be 35. Now, like we did on the front, we tried to build a factor tree for the number underneath the radical, the radicand, to see if we could break that down further with any perfect square factors. But if we look at 35, our only factors are 1 and 35 and 5 and 7. So since none of those are perfect squares, this one's done. All right, let's go over to number 7. So the numbers in front of the radical here are 1. So 1 times 1 is 1, so I'm not going to write that outside of my radical. And then I've got 21 times 7 is 147. So like I've done on all of the other radicals I've been breaking down, I'm going to go back. So 1 times 147. I could try 2, but that's not going to work. And then I try 3, and see that that goes in 49 times. That's a perfect square. So this will be square root of 49 times square root of 3. So together, this will break down to be 7 square root of 3. Okay, I'm going to pause the video right now, and I'm going to have you try numbers 9 and 10. You need to pause the video as well and give these a shot. Okay, let's see how you can. So multiply the numbers together on the outside. And it's 1 for underneath. So then the 34, we make that 4. Square root of 4 simplifies to 2. On number 10, multiplying the numbers outside, you get a 10. 6 times 15 underneath the radical gives you a 90. And then maybe by now you don't need to build a factor tree. Maybe you recognize that 90 is going to have a perfect square factor of 9 with a 10 as the other factor. And then the square root of 9 is a 3. 10 times 3 is 30 times your square root of 10. All right, let's take a look at numbers 11 and 12. On number 11, what's really happening here is this means you are multiplying square root of 23 by itself. So square root of 23 times square root of 23 is going to be the square root of 529, which is just 23. So if you are squaring a square root, they're going to cancel each other, and you can get right to your answer of 23. But this is the explanation as to why the square is canceling the square root. All right, if we look at number 12, and we take this is going to be 6 root 5 times 6 root 5, which will give us 36 times the square root of 25. Square root of 25 is 5. Multiplied by that 36 is 180. Another way that you can do that is to say you're going to square the 6, and then the square cancels the square root on the 5, leaving you with just 5. And then 36 times 5 is 180. Okay, so either way there works. All right, so we've got some mixed practice here. Let's actually jump down to numbers 17 and 18 and give you a chance to try what we just did on numbers 11 and 12. So pause the video and give these two a shot. I hope you noticed here that there's a difference in 17 and 18. So in 17, the 8 is inside the parentheses, meaning that it is also being squared. But on number 18, it's outside the parentheses, meaning that the square does not apply to that. So on number 18, the square cancels the square root on the square root of 2, leaving you with only 2. Then that 8 on the outside multiplies that 2 to give you a 16. Where in number 17, you've got to square that 8 and then multiply by the 2. So 64 times 2 gives you a 128. Okay, let's move up to numbers 15 and 16. If you want to pause the video and try these on your own, then you can come back and hit play again, and you can see the answers. Otherwise, you can follow along with me as I work. So 18 times 3 would be 54. I'm not going to build my factor tree here because I know my multiplication tables quite well. And so I know that 9 is going to go into 54 6 times. So this turns out to be 3 square root. If that's not something that you easily know that off your you should be over on number 16. 3 times 5 is 15 times the square root of 14 times 2, which is 28. Okay, we actually worked on square root of 28 on the front, so I know that 4 is the biggest perfect square that goes into 28, and that goes in 7 times. So we've got 15 times the square root of 4, so 15 times 2 times the square root of 7 is 30 square root of 7. All right, if we move up to number 14, so for 22, I've got 1 and 22, 2 and 11. Those are my only factors, and none of those are perfect squares. So in this case, we would say that this is already simplified. Okay, and then the last one that we're going to work on, number 13, 243. The biggest perfect square to go in there is 81. That goes in 3 times. You would have found that if you put your factor tree. So this is 9 root 3. Okay, so I hope that helps you understand how to simplify square roots. You can now go on to your simplifying square roots practice.